Hello students, Assalamu alaikum. I hope all of you will be fine. So today we will talk about the sampling methods which are used in probability and random variables. Basically we will use the urn examples here in which different balls are placed in urns and the user has to pick some balls with replacement and without replacement, and similarly with ordering and without ordering. This is the same thing we have discussed in our class at face-to-face classes in university. So today this is example 2.15, which will discuss the sampling method with replacement and with ordering. Okay, what is mean by replacement and what is mean by ordering? Ordering means that the order matters. If a user has come and has to pick one ball from an urn, one has number 1 over it and the other ball has number 2 over it, and he come and pick one ball. He comes and pick one ball. So either he will pick one first and then 2 in the second turn. Similarly, he can also pick 2 in the first turn and 1 in the second turn as well. So this is what is this. If order doesn't matter, you can say that he will pick 1 or 2. But if order matters, that you will say that he will pick 1 first and second, 2 in the second turn. Similarly, 2 in the first turn and 1 in the second turn. So if the order is important, then you can say that the 1 or 2 is different than 2 and 1. But if the order is not important, then you can say that he will pick balls 1 and 2 or 2 1. So in the second case, the orders are order doesn't matter. Okay. So here we are considering the case now in which order is important. 1 2 is different than 2 1. Similarly, what is meant by the replacement term? Replacement term means a user comes and he pick a ball. He pick a ball. Let's say there is ball 1, 2. It is written 1 over here and 2 over here. He comes and pick ball 1 and ball first, and when he will pick some ball, okay, let's say he will pick some ball, and after picking he note down its number, and after noting down the number he will put back again that ball into a bucket. Okay, so what is this? He is noting down the number and again putting the same ball into the bucket. So this is what is this? This is called sampling with replacement. Actually, he is sampling from the 2 balls. After noting down the number, he is again putting the same ball into a bucket. Similarly, in the second term, how many choices will he has again? In the second term, he again will have 2 choices. Okay. In the first term, he had 2 choices. In the second term, now again he will have 2 choices. Okay. He will pick the ball, or he will sample a ball from the bucket. He will take and observe its number. Let's say now he observed 2, and again put back that ball into a bucket. He will shake it, and again, how many choices will he have in the third third time? He again will have 2 choices. Okay, again, because he is not putting out any ball from the urn. He is sampling the ball. He is looking at its number. He is noting down and again putting it back into the bucket. So this thing is very important. Okay, sampling with replacement is the thing in which he has to take the ball. He has to look at his number and he has to put it back. Okay. So this is sampling with replacement. He is replacing again that ball with its original position. Okay. So let's discuss this example. These things will be cleared more in this example. In this example, an urn contains 5 balls. Okay. 5 balls and on each ball numbers are printed as 1, 2, 3, 4, 5. Suppose a user has to select 2 balls from the urn in which 5 balls are available. There are 5 balls in this urn. 1, 2, 3, 4, and 5. Sorry for my writing again. This is 1. This is 2, 3, 4, and 5. Okay. Different numbers from 1 to 5 are printed over the balls. Okay. So he comes and pick any ball with replacement. Okay. He will come, pick any ball, and then put it back again. It is with replacement, and how many turns will he have? He will have 2 turns in it. Okay. So kindly wait a sec. So much more. Okay. So he will have two turns because he has to pick 2 balls with replacement from the bucket. So what do you have to find? You have to find the probability that the 2 drawn balls give the same number. Okay. Initially you have to pick 1 ball out of the 5 random numbers. Again, the problem is a random problem in which you have to choose some random numbers. Initially you have 5 numbers you don't know. You have to just pick the number out of that 5 balls. You don't know which number you will pick. You don't know which ball you will pick. Okay. You have to pick that and you have to note down the number. You have to put it back, and again you will pick the ball from the urn. You will look at the number, and then you have to put it back again into the bucket. So you have no idea that which numbers you will get and how many numbers you will get. But it is asking you the chance of finding the same number in the two turns. Okay, what is the chance? So first of all, we have to find the total number of distinct order pairs you will get from the sampling. So here, okay, so it is again that problem which we have done earlier, that you have again 2 places. Initially you have 5 balls, so you have 5 choices, and out of that 5 choices you have to pick a ball. So initially in the first box, in the first you can say that in the first slot you have to write a number out of these 5 numbers. Okay, you have 5 choices. After picking the number, you will put back the ball and again pick the ball. In the second turn you will again have 5 choices because now you are again replacing a ball with this same ball. Okay, so this is again 5 and 5. How many choices will you have? You will have 5 multiplied by 5 total choices, and it is 25. Okay, it is 25. Similarly, if you guys have to pick 3 numbers, so how many choices will you guys have? That would be 5 multiplied by 5 multiplied by 5. So these will be the choices you will have in this scenario, and it would be 5 cubed. So these are the total number of order pairs in a sample space. These would be the number of order pairs in the sample space. You will need it. You will need it for finding the probability of the said event, which is asked from you. Okay, let's move on. Let's look at the solution. Okay, this is the solution. So again, you can see that you have in a sample space, you have 1, 2, 3, 4, 5 balls. How many ordered pairs are possible? These are the ordered pairs which are possible. Either you can get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. So these are the total number of ordered pairs, and you can count them. These are basically 25 ordered pairs. Okay. So what do you want to find? This is the first question which is asked from you. Now you want to find out the probability that the two balls which are picked having will have the same number. These all the elements which are at the diagonal. These are the these are the required outputs. Okay. Out of these 25, these 5 are the required output. Either you should have 1, 1, either you should have 2, 2, you should have 3, 3, you should have 5, 4, 4, or you should have 5, 5. These are the two, these are basically the two balls which are same in number in the two turns. So you have to find the required set will be B, and how many elements we have in B? We have in B 5 elements. In sample space, we have 25 elements. Okay. So according to the formula which I have told you earlier, that the probability of any event is equal to the number of the event in that with the number of the element in that event divided by the total number of the events in a sample space. So here you have 5 divided by the 25. It is 0.2. Okay. So this is the first example, and first thing we have seen in this sampling with the placement and with ordering. I think it's clear now. Let's move on. Sampling without replacement but with order. Now you can see that again the same problem is there, that you have to pick something, you have to note it down and put it back into the original space from where you have picked it up. But here now the scenario is different, because there is another term which is ordering and without ordering. Now we are considering another thing which is with order. Okay. Sorry, actually here sampling, initially we had sampling with replacement, now we have sampling without replacement, but order is the same. Again order matters, but actually now we have sampling without replacement. You have to you have to pick up the ball, you have to note down its number, and then you will not put it back into its original position. Okay, now that is called sampling without replacement. Okay. And sampling without replacement, you don't have to replace with the initial elements. Okay. So let's talk about the same example. An uncontained 5 ball number 1 to 5. Again, we have an un. Okay. We have 5 balls in this un. Okay, we have 5 balls in this one. Again, the numbers written over these balls are 1, 2, 3, 4, 5. Okay, these are 5 balls. How many distinct order pairs are possible now? From this example, you have to find the total number of the order pairs which are possible with this specific condition without replacement and with order. Now you can again use the same slot problem. Okay, when you will pick up first number, first ball or first number from the end, you will have 5 choices. Okay, but when you will pick a number and will not put it back into the urn, you will have 4 balls left in the second turn. Okay, so what will happen? You will have total 5 multiplied by 4 means 20 total choices. Okay, because now the all the terms having the same numbers in the first and the second turn will be vanished. You can see that the diagonal elements are now vanished because it is not possible now here. If you have if you have picked up the ball and you are not putting it back, you cannot get the same number in the second turn. Okay, so this thing is not possible in without replacement. Similarly, if you have to pick 3 balls, means you will have 3 starts, you will have 3 choices in the third term, and so on. Okay, because you have initially you have total number of balls, you have picked a ball, and in the second term you are left with 1 less of the initial number of balls, and in the third turn you are now having 2 less than the original number of balls. So now how many choices will you have here? You will have 5 multiplied by 4 multiplied by 3 means you will have 60 choices now here. Okay, with 3 turns or 3 ball selection. So this is sampling without replacement, but with ordering. Let's move on. This is the same thing which we have discussed. That suppose that you have 3 balls succession without replacement. So without replacement, you will have 5, 4, 3. First, in first one you will have 5 choices, and 4, then 3. Okay. Similarly, if you have to pick 5 balls in succession, initially you will have 5 balls. In second, you will have 4 balls, and in third, you will have 3 balls. In fourth turn, you will be left with 2 balls, and at the end you will have just 1 ball. Okay, you are just picking a ball and not putting it back into the bucket, so you will be left with these choices. And how many choices will you have? This would be the 5 factorial choices. This is the common term for factorial, excuse me. Okay, so sampling without, if you are replacing something, if you are replacing without replacement, but you have the total number of elements or total number of terms are equal to the total number of elements, then the problem will be solved via the factorial term. Okay, let's move on. There's some noise behind me, so I'm again sorry for that, but I'm trying to convey what is the concept behind all these terms. Okay, example 2.17, an uncontained 5-ball number numbered, suppose again 5 balls numbered from 1 to 5. Suppose we draw 3 balls with replacement. What is the probability that all 3 balls are different? Okay, in this problem we saw that we had a question in which we have to find the probability that we draw 2 balls in which the ball number will remain the same. Okay, but here the nature of the example is somehow different, in which we have to find the probability that the 3 balls picked will have different numbers over. So, and then contains again the 5 balls, so 5 ones, and we are using again with replacement. Okay, so in with replacement, how many items will you have? You will have 125 number of order pairs. Okay, this is the same formula which we had earlier. So this is with replacement order pairs. But if you are considering the case in which the 3 numbers will be different, Okay, how would it be possible? Now here in in first in first in first scenario, let us have five choices. In the second scenario, you will have four choices, because the problem is now with replacement. But why you are looking at this problem like this? Because you want all the three numbers in uh, all three numbers different. Okay, all three numbers should be different. So initially you will have five choices. If some number is picked up here, it shouldn't come next again. Okay, and it shouldn't come. If two choices we have done with the two choices, the third number should be different than the first two numbers. So now here we should have how many choices? We should have 5 multiplied by 4 multiplied by 3 choices. So now we want 60 out of 125 choices. So it would be the probability of the different balls. Okay. This problem is also in your book. Just use the concept of the two terms which we have done earlier, that initially the problem is with replacement, but the thing is, but the statement which he wants, the probability of three different balls, the three balls can be strictly different if the condition is without replacement. So that's why in the uh, in the numerator term, we will use the three balls with without replacement, without replacement. Okay, let's move on. Permutation and combination. Okay, permutation and combination are two terms in which which we will be using very randomly in this course. So what is a permutation? In permutation, the order is very important. Let's say we have the key to a safe is 472. Order is important, and the code 472 is not the same as 742. Okay, if you are putting 472 instead, if you are putting 742 instead of 472, the safe will not be open. Similarly, if you have a mobile phone and the code of a mobile phone is uh, 1702. Okay, this is a code. If someone comes and he writes 2017, okay, actually the numbers are same. You can see numbers are basically same. You can see, but the code will not allow a user to enter into the mobile phone. The mobile phone will remain locked. What has happened? Because the numbers, the order of the number is very important. So the code you will have will be a certain type of, certain case of a permutation. Okay. Sampling with order. This thing is again when sampling with order, as was shown in previous example, order 1 to not same as 2 1. This is a case of permutation. Example 2.15 can also be rephrased as if find the number of permutation. The previous cases in which we want the order is important are the cases of permutation, and similarly example 2 can also find the number of arrangement order without replacement. So those were the previously whatever we have done are the cases of permutation. Okay. So what are the combinations? Combinations are the things in which order is not important. Let's say you have some arrangements just like 0 1 and 1 0. So now how many permutations do we have? We have basically two permutations, but how many combinations do we have? We have just one combination. Okay, because now order doesn't matter. The order of 0 1 1 0 doesn't matter, but their combination matters. Similarly, in a deck of cards, we have a hand of cards in which we have A, J, 9, 7, 5. So we can see that how many we will have. These will show different permutations, but the combination will be only one. Okay, so that is the difference between combination and permutation. In permutation, order matters, but in combination, order doesn't matter. So I stop at this point in this video. We will talk about different terms in our next video. Till then, Allah Hafiz.